Hello, welcome back to Learn Physics. In today's video, we are going to discuss about the rest of the numericals from that exercise. Okay, so in last video we did till our in page number 128 till 11th question we did. So today we are starting with page number 129, 12th question. According to the third law of motion, when we push on an object, the object pushes back on us with an equal and opposite force. If the object is a massive truck parked along the roadside, it will probably not move. A student justifies this answering that the two opposite and equal forces cancel each other. Comment on this logic and explain why the truck does not move. See, and when we push an object, the object will push us back, isn't it? With an equal and opposite force. That is the Newton's third law of motion. If the object is a massive truck parked along the roadside, it will probably not move. The reason behind that, see, force acting on A due to B will be equal to minus of force acting on B by A. Here force is acting on A, here force is acting on B. Then how it will be cancelling because of that? Here force is acting on A, isn't it? A force is acting on A from this direction and acting on A from the opposite direction, then total force will become equal to 0. But here, as per Newton's third law, force acting on A due to B will be equal to force acting on B due to A in opposite direction, isn't it? So whether it will cancel each other because of that, so the student's statement is wrong. It is a wrong comment. Okay, then what will be the reason the truck is not moving? The truck is not moving because, yes, a frictional force is acting on it. See, this is the truck and we are applying a force on it, and while we are applying a force on it, in opposite direction a frictional force will be acting. So if the object needs to move, means we should apply a force greater than, if F is greater than frictional force, then the object will move. F is less than frictional force, then the object won't move. So you understood what is the reason the object is not moving? The object is not moving because the frictional force is opposing the applied force. Okay, clear for you? Then next question, 13th one. A hockey ball of mass 200 gram traveling at 10 meter per second is struck by a hockey stick so as to return it along its original path with a velocity 5 meter per second. Calculate the change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. A hockey ball of mass 200 gram traveling at 10 meter per second. So its initial velocity is 10 meter per second. It is struck by a hockey stick so as to return it along its original path with a velocity 5 meter per second. Okay, so final velocity second, we are giving a velocity of 5 meter per second. See, so as to return it along its original path with a velocity at 5 meter per second. So this is the return, isn't it? Opposite direction. So velocity is negative. Calculate the change of momentum occurred in the motion of the hockey ball if the force by the force applied by the hockey stick. So how we can find out the change in momentum? Change in momentum equals momentum. Momentum, how we can find out? P equals mv. Change in momentum delta P equals mv minus mu. Okay, so m is 200 gram we can convert it into kilogram, so it will be 200 divided by 1000, so it is 0.2 kilogram. So it is 0.2 into minus 5 minus 10. So what is 0.2 into minus 10 minus 5 minus 15. 15 twos are 30. So it is minus 3 meter per kilogram meter per second. This is the unit of change in momentum. So minus 3 kilogram meter per second. So it is negative. Unit of momentum is m into v. M is kilogram, v is meter per second. So it is kilogram meter per second. So minus 3. Minus 3 means change in momentum will be acting along which direction? In the second motion, isn't it? Along its original path. Okay. So the next one is 14th one. A bullet of mass 10 gram traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 seconds. Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of the force exerted by the wooden block on the bullet. Okay, so a bullet of mass 10 gram. So 14th one, mass of the bullet is 10 gram traveling horizontally with a velocity of, initial velocity 150 meter per second. Strikes a stationary wooden block and comes to rest in 0.03 seconds. So it is coming to rest in 0.03 seconds. So time required is 0.03 seconds and it is coming to rest position. So that is V is equal to 0. Okay, and calculate the distance of penetration of the bullet into the block. So distance travelled inside the distance of penetration of the bullet into the block. So that only we need to calculate, and also calculate the magnitude of force exerted on the wooden block in the bullet. Okay, so we have V, U, T and all. How we can find out? S is equal to UT plus half AT square. For that we need A, right? So for how we can find out? V equals U plus AT. So V is equal to 0, that is equal to 150 plus A into T is 0.03. So A equals minus 150 divided by 0.03. So it is 50 into 10 to the power 2. 5 into 10 to the power 3 meter per second square. So this is acceleration. So if we are applying acceleration here, 150 into 0.03 plus half into 5 into 10 to the power 3 into 3 divided by 100 the whole square. Half AT square. A is minus, right? So here minus sign. So in minus 150 divided, retardation it is 150 into 4.5 minus 5 by 2 into 9 divided by, what is this? 10 to the power 3 divided by 10 to the power 4 is 10. So it is 9 by 2, 4.5 minus 2.2, you will get it as 2.3 meters. Like that we will get the displacement. So you understood how we are finding out. So mass of the bob is given, initial velocity, final velocity is 0. We need to find out S. How we can find out S? S is equal to UT plus half AT square, or you can use V square minus U square equals 2AS. Any one formula you can use. Anyway we require A. For that first we are applying in this equation and we got it as retardation minus 5. Minus 5 into 10 to the power 3. Okay, that is 5000 meter per second square. So that one we are applying here and we are getting the value of 2.3 meter here. Okay, so this is the distance covered. Now we should find out the force applied. How we can find out the force? So force F equals ma. Isn't it? As per Newton's second law of motion, F is equal to ma. So what is the mass? 10 gram. That one we should convert to kilogram by into 1000. Acceleration is minus 5 into 10 to the power 3. So this 10 to the power 3 and this 10 to the power 3 will get cancelled. We will get it as minus 50 Newton. This will be the force acting. So while getting a numerical, don't get panic and identify the, first you write down the data. Then itself you will understand what we should find out. So we will get a clarity about it. And if you have any, if it is needed means you can draw the diagram. But in this case, central diagram is not required. So the data, once or twice you can read the question and then write down all the datas. Okay, while you are writing down the data itself, you will understand how to do and which equation we should use. For that, first thorough with your equations. Okay, all the formulas you should learn thoroughly, and whenever it's a free time, you just write down and see once, isn't it? Before taking a break, you can write down all the equations once, so it will be there in your mind. Okay, so that will be easy for them doing the numerical. Instead of always cursing the numericals, oh numericals are difficult like that, you can apply this method. Okay. So next is 15th one. An object of mass 1 kilogram traveling in a straight line with a velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kilogram. Then they both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of the combined object. So, 15th one. An object of mass. How much it is? 1 kilogram. Traveling in a straight line with a velocity of 10 meter per second. So that is u, with a velocity, initial velocity 10 meter per second, collides with and stick to a stationary wooden block of mass 5 kilogram. So this is a object, mass of object, initial velocity of the object. See, it sticks to a stationary wooden block. So mass of wooden block, that one is 5 kilogram. It's stationary. So initial velocity of the wooden block also will be equal to 0. Then they both move off together in the same straight line. Calculate the momentum just before the impact and just after the impact, and also calculate the velocity of the combined object. So after that, both are moving with the same velocity, isn't it? Both are move off together in the same straight line. So which formula we can use? See, all these are given. After that, m1, so mo plus mw will happen. That will be moving with the velocity v. Okay, this is after collision. There itself we will get an idea, isn't it? What is that? See, if it is sticking together and then it is moving with the velocity, means how we can find out what will be the formula? Yes, moment conservation of momentum. Total momentum before collision is equal to total momentum after collision. So mo uo plus mw uw will be equal to mo plus mw into v. Final velocity. So mo is given as 1, uo is given as 10, mw is 5, uw is 0, mo plus mw is 6 into v. So what will be? See, 10 equals 6v. So what is v? 10 divided by 6, that is 5 divided by 3. So 1.6 meter per second. Okay, so this is the velocity. Calculate the total moment, also calculate the combined velocity of the combined object and total momentum before the impact. Before the impact, what will be the total momentum? 10. So momentum before the impact. Momentum before impact. How you will find out? MOUO plus MWUW. Okay, MO is 1 into 10 plus 5 into 0. So it will be equal to 10 kilogram meter per second. Okay, clear? Next is 16th one. An object of mass 100 kilogram is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. Calculate initial and final momentum of the object. Also find magnitude of the force exerted on the object. See, an object of mass 100 kilogram. So 16th one is mass of the object is 100 kilogram. Is accelerated uniformly from a velocity of. So u equals 5 meter per second. It is to which velocity? 8 meter per second. 5 meter per second to 8 meter per second. So 5 meter per second is the initial one. Final one is 8 meter per second. Time is given as 6 seconds. Calculate the initial momentum and final momentum of the object. So how we can find out the initial momentum? Initial mass into initial velocity is initial momentum. Mass into initial velocity. So same way final momentum will be equal to mass into final velocity. So mass is 100 into 5, that is 500 kilogram meter per second. So then 100 into 8. So it is 800 kilogram meter per second. So here they are asked to find out the magnitude of force exerted on the object. How we can find out the magnitude of force? Delta P dP divided by dt. This one we learned, right? What is this? F is equal to dP by dt. Newton's second law. What is the change in momentum? See, final momentum minus initial momentum divided by time is 6, isn't it? So 300 divided by 6 equals 50 Newton. This is we can find out. Okay, so let's say how you are identifying all these things is the theory should be thorough for you and the equations also will be. So while you are doing, since it is from this chapter, we can easily recollect the formula. While you are doing in a summative assessment, at that time what will happen? All the formulas together it will be coming. So you should identify from those. Okay. 17th one. Akhtar, Kiran and Rahul were riding in a motor car that was moving with a high velocity on an expressway when an insect hit the windshield and got stuck on the windscreen. Akhtar and Kiran started pondering over the situation. Kiran suggested that the insect suffered a greater change in momentum as compared to the change in momentum of the motor car. Akhtar said that since the motor car was moving with a larger velocity, it exerted a larger force on the insect, and as a result, the insect died. Rahul, while putting entirely new explanation, said that both motor car and the insect experience the same force and a change in their momentum. Comment on these suggestions. See, these three were riding a motor car that was moving with a high velocity on an expressway when an insect hit the windshield and got stuck on the windscreen. Okay, the reason. So Akhtar and Kiran started pondering over the situation, and Kiran suggested that insects suffered a greater change in momentum as compared to the change in momentum of the motor car. Okay, Akhtar said that the motor car was moving with a larger velocity, it exerted a larger force on the insect, and as a result this insect died. Rahul, while putting an entirely new explanation, said that motor car and the insect experience the same force and a change in their momentum. So what will happen if, the car, it was moving with a high velocity, isn't it? Car was moving with a high velocity. Insect will be compared to the car, the velocity of the insect will be very less than the velocity of the car. Okay, suddenly velocity is coming to high velocity. So change in velocity will be more. Change in velocity is more. So what will happen? Change in momentum also will be more. So force experienced will be more because F is proportional to dP by dt. In a very short interval of time, very high change in momentum. So force acting on also will be more. That is the reason. So who said the correct one? So who will be experienced? Yes, Rahul, where both motor car and insect experience the same force and the change in their momentum. So whose was correct? Rahul's explanation was correct because both motor car and the insect experience the same force. Force will be more, isn't it? And the change in their momentum. Same force and change in momentum also will be more. So Rahul's explanation is correct. You understood what is the reason? Okay. So next is, how much momentum will be a dumbbell of mass 10 kilogram? 18th one. Mass 10 kilogram transferred to the floor if it falls from a height of 80 centimeter. Take a downward acceleration to be 10 meter per second square. So we need to find out the momentum. Mass is given as 10 kilogram. It's coming from a height of 80 centimeter. So centimeter to meter conversion divided by 100. So it is 0.8 meter. Okay, acceleration G equals 10 meter per second square. So how we can find out the momentum? So S is here, G is here. So how we can find out the momentum? So initial velocity, what is the initial velocity? It falls from a height, isn't it? Falling from a height means initial velocity. Dropping, it is equal to dropping. It's not throwing. If throwing means initial velocity will be there. How we can find out? V square minus U square equals 2AS. So if we are finding out V, that is equal to root of 2 into G is 10, S is 0.8. So how much we will get? Root 60, that is 4 meter per second. That will be the velocity. Then momentum will be equal to mass into velocity. Mass is 10, V is 4, so it is 40 kilogram meter per second. So you understood how we are getting this one. So here final velocity we are finding out, then finding out the momentum. Okay, clear? So it's clear for you, right? So these are the important exercise questions in this chapter, and actually theory wise not that much in this chapter, only first law, second law, third law and some of its applications, inertia, and then its conservation of momentum. Then one more thing is there, force is directly proportional to dP by dt. Using that you can find out the F is equal to ma, that equation, that also important one. Okay, so these are the major things in the theory portion, and so many solved examples are there in the textbook. Please try to solve that. Okay, so I hope all of you understood all these things, and all this chapter also clear for you, I guess. And in the next video I will be coming with the next chapter. Okay, so if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.